Hello everybody and welcome to this lesson. Today we will discuss about process selection. Last time we have discussed about product selection. In the case of product selection, we have seen product selection is necessary in order to be competitive in the market, and product lifetime is limited, just like human being. Products born, live and die. So we need to develop. It is a must to design and develop and deliver new products every time to the market in order to be competitive in the market. Just like product selection, process selection is also a must. Once we have to produce a new product, we have to have a process selection. We have to have a new process selection that is conducive or that can make us to. As we defined before, designing is a process of satisfying people's requirements through shaping or configuring product, service, and process. Thus, to achieve that design, we need to have a process. We need to have a process that is process selection. Process selection is choosing the process that enables the operation to produce a specific product. A specific product, or it refers to deciding on the way production of goods or services will be organized or delivered. In the previous discussion, we have defined that operation management is the activities of directing, developing, delivering, and designing activities in the organizations. So this designing part includes both process design as well as product design. By the way, both product design and process design cannot conduct isolately. We are doing process design as far as there is product design. This figure clearly shows that the design of the process cannot be done independent of the service or the product that they are creating. Once we have a product or service that we are creating, so there should be a process that should be designed so they can create all the products and services which the operation is likely to introduce. So as there is product selection, there should be also process selection. So we are doing together. We cannot do product design without process design. If there is new product design, there should be also new process so as to produce that new product or new service. From this onwards, we will see the types of processes. The types of process should be categorized based on the volume and the variety of the products. According to the volume of the production, that means how much the product that we are going to produce, and the variety of the products, the variation of the products in the process, we can categorize into two major divisions, and we can also categorize into 5 subdivisions, because we have to have many process selection, because no one process fit all the demands. No one process fit all the demands of the consumers. Some consumers want some specific special equipment or special product according to their specification, and the other may need some common types of goods and services. In general, no single process fit all the required demands of the consumers. So process types can be divided into two major divisions, intermittent and continuous, according to the volume, the flexibility, and the variety of the products. We can also categorize into 5 types based on variety and the volume of the products, which are project, job, batch, mass, and continuous. First, let's see project process. Project process has high variety of product and low volume of product. In the project process, we can achieve high variety of product and low volume of product. And it is used to make products based on customer specification. This is the reason behind to be high variety customer specifications. We will use this process when we are requested to produce according to the customer's specification. If we take an example of the Grand Ethiopian Renaissance Dam project, probably there is no other project which is exactly the same to this project. This project is required by Ethiopia, so it has different specification. It has specialized specification which is applied only in this dam. Because of the customer specification, there is high variety, but low volume. For example, this project is a single project. It is constructed based on the Ethiopian government specification, And because of it is a huge product, transferring resource to the place where the product is made is necessary. We have to transport all the resources required for accomplishing this project to a place where the project exists, to a place where a project constructs. Because it is huge, we cannot transport the dam just like other products. So it is necessary to transport inputs necessary to construct the dam. It needs professional judgment and setup occurs between the products. We have to set up, if we want to construct another dam, we have to set up our equipments. Again after we finish the Ethiopian Renaissance Dam project. If we want to construct another dam, so we have to set up our equipment so as to fit the new dam, the other dam. And it needs professional judgment because the process may be complex. The process of constructing a project, the project process is complex by its nature. And it requires, since it is a complex nature, it requires coordination of many individuals and activities. And demand a problem-solving approach to ensure they are completed on time. By the way, in the meantime, while we construct the projects, we may face different types of challenges in the meantime. So we have to solve that problems in the meantime, and in order to ensure the completion of the project within the period, within the scheduled time. The time scale of completion of the project is an important performance measure. The best performance measure in the project is to complete on time. Completions of the project on time is the best criteria to measure the project performance. What is the reason behind? Can you tell me one reason why time scale is so important than specifically the cost? Okay. The time scale is so important than a cost because the aim of the project is to solve the problems. In the case of the Grand Ethiopian Renaissance Dam, we are expecting the dam to solve the shortage of electric power. So that is the main objective. So completing this project within the time may also related to solve the electric shortage within the time. If it delays, the electric shortage also exists for longer period of time. And in relation with electric power, there are a lot of investments that can face a bottleneck. So one of the reasons is that, and delaying a project by itself also relates with a cost. Once we delay a project, so it is related to incur to a higher cost. It's related to higher costs. So time scale is an important or a crucial parameter to measure the performance of the project. Some specific examples of the project process is a dam, road, building construction, interior design, custom built furniture, software, and so on. This is the second process, that is jobbing process. Jobbing process is characterized by high variety and low volumes, just like that of the project process. And many jobs will probably never repeated, and some may be repeated. Unlike that of the project that we have discussed before, the product share resources with many others. And in this case, general purpose machine may be used to produce different needs to achieve or to satisfy different needs of the customers. This craftsman, for example, is using general purpose wood cutting machine in order to produce different types of woodwork product. This craftsman is using general purpose wood cutting machine. Relatively, it is complex, less complex than that of the project. However, they usually produce physically smaller products. Unlike that of the project process, it produces smaller products and also sometimes require considerable skill. And such process often involve fewer unpredictable circumstances. That means we are sure that we are going to produce. We are sure we know what we produce. There is no challenge, there is no unpredictable things that we face in the process. Unlike that of the project process, here there is fewer unpredictable. And the third one is batch process. Here, medium variety and medium volume. It's characterized by medium variety and medium volume of products, and may look like job process, but do not have same degree of variety. If the size of the batch is just 2 or 3 items, it is little different from jobbing. It's almost similar to the jobbing. And the name indicates each time more than 1 item produced. Within a batch, there are a lot of items. Periodically, the process repeats. After one batch, the second batch will be produced. And the products are grouped as they move through the design process. As they move from initial to the final, so we can categorize the batches. We can categorize the groups into batches. If we consider the university classes, so we can categorize the first batch, the first year batch, second year batch, the graduating batch, and so on. So along the process in the university, so we can classify into different batches. And the setuping occurs between the batches. Once we finished one batch, so setuping occurs. And resources are shared between the batches. Resources are also shared between the batches in the university. Within that university, the classrooms are used for different batches of students. And setuping occurs between the batches. A lack of coordination can lead to many products waiting in the process because the batches are in the process. Here, for example, in the university, there are 3 batches, the first year, second year, and third year. So once if there is an obstacle in the third year, so the first year and the second year may not finish because they are using the resources commonly. They are using common resources. So a lack of coordination can lead to many products waiting in the process. For example, the book printing, university class, and closing are an examples of batch process. And the next is line or mass process. This process is characterized by high volume and low variety, and usually repetitive and largely predictable. Types of products, because there is low variety, so we can predict the product. The movement of the product may be automated using conveyor system. Here we can use an automatic machine like conveyor system, and the production process broken down into a number of small and simple tasks. And we can use here specialization by dividing the tasks into a number of small tasks, so we can use specialization. Due to low variety, setuping of the equipment is minimized. Because of low variety. Minimized, and utilization of the equipment is high. We can utilize the machines highly. High volumes of product results cost effective. Because of high volume, we can be cost effective. This result is cost effective to use specialized labor and equipment, because our cost with regard to a single product will be less. Because of the higher volume of the production, a cost incurred or products per cost is higher, or cost per product is lower. Because of the high volume of the product. Here, an important concept, an important point is line balancing. Line balancing is essential for ensuring a smooth flow of the product. That means the speed of those machines, those interconnected machines, should be synchronized. For example, once this machine starts and finishes its work, this machine should be ready, and all the machine's speed should be synchronized. This is what we call line balancing. Line balancing is essential for ensuring the smooth flow of the product. An example of line or mass production is cars, television, and food items. And this is continuous process. In continuous process is characterized by very high volume of products and standardized products than mass production. It's a very standardized product, or we can simply say that it produces a single product. The machines or the equipments are specialized and dedicated to produce a single product, which is a standardized product, such as an oil refinery, and there is high investment. The continuous process needs high investment. It is capital intensive, and it is relatively inflexible with highly predictable flow. Because it is dedicated and it is specialized equipment to produce a single product, it is relatively almost inflexible. By inflexible, which means the dedicated line, for example, if we consider this transmission line, which transport electricity from generation to the distribution, so it is a dedicated line which transfers a single product, so it is inflexible, or it is not flexible to produce another product or to transport another product. It's a dedicated line, so it is inflexible. And the role of labor is mainly to monitor. The supervisor or the staff is to monitor this activity, to monitor and control the process in the equipment with a little contact, less labor contact. Here, there is less labor contact with the product. If we consider this transmission line, it transports electricity from generation to distribution. And here, there is a continuous process. It is a continuous process with 24/7. And if we consider this water treatment plant, here is also a continuous process, and it is a dedicated machine which treats only water. So it is inflexible. That means it is not possible. And then the next is service. Just like that of manufacturing, we can also categorize service processes based on variety and volume of the service provided for the customers. Service can be categorized into three: mass service. Mass service, as the name indicates, have many customer transactions. As you see here is a train station in China. There are many customer transaction involving limited contact time, but limited contact time. For example, here there is a door, a check-in door. So here there is limited contact, and because of this mass service, because it provides mass service, there is little customization, only very limited customization, and staffs are likely to have relatively defined divisions of labor. There is divisions of labor to serve this mass service. To provide this mass service, every staffs have defined divisions of labor and have to follow set of standardized procedures in order to serve this huge amount of customers. For example, supermarkets, railway networks, an airport, teleservice, library, and police service are some of the examples of mass service. And the second is service shop. Service shops is characterized by less volume of service and relatively high variety than that of mass service. And there is customer contact, and there is also customization, and the staffs have relatively discretional power. And it is found between the professional service and the mass service. It is found within the two extremes, that is professional and mass service. The mass services that we have discussed in the previous slide, and professional service is that we will discuss next. For example, banks, high street shops, car rental companies, schools, most restaurants, hotels, and travel agents are among the service shops. As you see, here is a service shop example. So here there is a customer contact, and there is customization of the service according to the customers, and the staffs have some discretional power. And the last one is professional service. Here, high contact process where customers spend a considerable time. Unlike that of the mass service, there is here high contact process where customers spend a considerable time in the service process. For example, if you take this surgery, so the contact is high, and the customer stays for a longer period in the surgery process, and high level of customization is necessary according to the characteristics of the sickness features. The surgery is different for different individuals, so there is high levels of customization. People bet than machines and discretion in the serving customers. It is people based. As you see, it is people based than machine based. So there is high customer contact, and the discretion power is also higher. The discretion power for these doctors is higher. An example for professional services: consultant, lawyers, practice, architects, doctors, surgeries, auditors. This figure clearly shows all the processes at a time. For example, the project process is characterized by high variety and low volume, and continuous process is characterized by low variety or standardized product and high volume, very high volume. And along the process, it shows the extent of the variety and the volume of the products. In terms of process flow, the continuous process and the mass process may be categorized as continuous process, and the project process, the chopping process, can be categorized into intermittent process flows. According to the process tasks, these end processes are categorized by diverse and complex tasks, whereas this end process is characterized by repeated and divided tasks. And the same is true for the service process types. The professional service is characterized by high variety and low volume, whereas the mass service is characterized by low variety. This table shows that the difference between intermittent and repetitive operation based on these criteria, based on these parameters, it shows the difference between the repetitive operation and the intermittent operation and the repetitive operation. For example, in terms of product variety, great variety here and low variety in the case of repetitive operation. Degree of standardization, low in the case of intermittent and high in the case of repetitive. And if we take factors of driving production, here is customer's order in the case of intermittent. If we take project process and forecast of the future demands in the case of repetitive operation, we are producing the products by forecasting the demands of the future rather than the customer's order, unlike that of the intermittent operation. In terms of critical resource for the intermittent operation is labor intensive. It is labor, workers' skill is important here. But in the case of repetitive operation, since it is capital intensive, the main resource are equipment, automation, technology are important here, very important. Types of equipment, general purpose in the case of intermittent, and specialized, dedicated equipments are used in the repetitive. Degree of automation, low in the case of intermittent because it is labor intensive, whereas in the repetitive operation, it is very high automation. From time, longer in the case of intermittent operation and shorter in the case of repetitive operation because we are using specialized equipment, automated equipment. Work in process inventory, more work in process is found in intermittent operation, whereas less in the case of. This table shows the operation performance objective in one column here, and these are the operation performance objectives: the quality, speed, dependability, flexibility, and cost, and the typical process design objectives. These are the corresponding typical process design objectives. For example, to ensure the quality, the typical process design objective is provide an appropriate resource, error-free processing. In order to speed up the operation performance, the process design objective is minimum throughput time, output rate appropriate for the demand. In order to assure the dependability, the typical process design objective is provide dependable process resources, reliable process output timing and volume, and so on. This column is all about some benefits of the good process design. The typical process, here is the typical design process objective, and these are the benefits of the good process design. By getting these benefits or by achieving these objectives, we can assure the performance of the operation. We can achieve these operation performance objectives. These are operation performance objectives. Let's do one example. Before doing the example, let us see throughput time equals work in progress times cycle time. Throughput time means the time required to accomplish one activity. The total time required to achieve an activity equals work in progress times cycle time. Cycle time is the time required to serve a person. The time required to serve a person. For example, if 10 people are in the system, that is the work in progress, and 1 minute is required for serving a person. So the throughput time equals 10 times 1, that is 10. 10 minutes wait. 10 minutes is the total time required to serve 10 people. Let's do the example. Every year it was the same. All the workstations in the building had to be renovated. That means renovation is doing every year. It is a usual process. Tested, new software installed, etc. And there was only 1 week in which to do it. 1 week is required to do the renovation process. The 1 week fell in the middle of August vacation period, when the renovation process would cause minimum disruption to the normal working hours. By the way, in the vacation period, the renovation process causes minimum disruption. And last year, the company has 500 workstations, and all had been renovated within 1 working week, that is 40 hours. 1 working week is assumed to be 40 hours. So 500 workstations had all been renovated within 40 hours. Each renovation last year took on average 2 hours. Each renovation takes 2 hours, and 25 technicians are involved, had completed the process within the week. This year, there would be 530 workstations, that is, the workstations increases by 30 to renovate, but the company's IT support unit had devised a faster testing and renovation routine. Testing mechanism become faster than last year, so that would only take on average 1.5 hours instead of 2 hours. Last year, 1 renovation process takes 2 hours, but this year, because of the faster testing and renovation routine, it takes only 1.5 hours. Thus, how many technicians will be needed this year to complete the renovation process within a week, or within, that means 40. We know that throughput time equals working process times cycle time. So last year working process is 500, but this year 530, and the time available for both year, for this year and last year, is 40 hours. Average time to renovate last year 2 hours, but average time to renovate for this year is 1.5 hours. So the total time required, the throughput time required to accomplish is working process times 2 hours. That means 1,000 hours needed by 1 employee. If we have only 1 employee, the total time required to accomplish the task is 1,000 hours. Since we have 40 hours, we need to divide. We only have 40 hours. We need to divide 1,000 hours by 40, so we get 25. So these 25 employees can accomplish the 500 working process task with 40 hours. And the same is true for this year. We also use the same procedure. Working process is 570, and the time available is the same, that is 40, and the average time to renovate is 1.5 hours. If done by 1 employee, if it is done by 1 employee, it needs 530 times 1.5, this one. So it takes 795 hours, that is total time, throughput time. Thus, when we divide 795 with 40 hours, 40 hours, 40 hours. So we get 19.88, approximately 20 employees. So these 20 employees can do the jobs within 40 hours, 14 hours. This is all about today's discussion. If there is a question or a comment, you can write it below. Thank you. Have a good time.